warahmatullahi wabarakatuh. My name is Nurshahira binti Muhammad Sofian. My number ID is 2022467506.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. My name is Muhammad Razim Rizwan from class C2 course Civil Engineering Part 1.
Assalamualaikum, my name is Na'ala Misara binti Muhammad Khairuz. My ID number is 2022601406.
So, the first is, what is a differentiation? Differentiation is a method of finding a derivative of a function. It's also processed in math, where we find instantaneous rate of change in a function based on one its variable. The most common example is the rate of change of displacement with respect to time. It's called velocity.
So guys, let's move on to the next topic. So, the real question is when we do need to apply the differentiation. So, we use the differentiation to determine whether the function is increasing or decreasing. Let's say, if you differentiate a number and you got positive, it means the graph is increasing. Meanwhile, if you differentiate the number and you got the negative, so we will say it as a negative or decreasing differentiate. You understand, right? Okay, let's move on to the next topic.
Other application of differentiation is rate of change, increasing and decreasing function, concavity graph and critical point. For example, we use differentiate method for concavity graph. We also use this method to find concave up and concave down. But for this question, we use differentiation to solve maximum and minimum problem.
So hi guys, we meet again. So today I'm gonna tell you the most reason, the big reason why we do need to solve the maximum and minimum problem. The real reason is we, as a developer of a company, we must estimate the real amount of using the material so that we can reduce the waste material after the project is done. So the process of solving the minimum and maximum problem is called optimizations. It is really important in a big company so that we can reduce the wasting in money, human made and else. Okay, let's go to the next topic.
So, for the next is step for solving maximum and minimum problems. For the first step, we need to draw an appropriate figure and label the quantities relevant to the problem. For the second, find a formula for the quantity to be maximized or minimized. Identify the quantity to be maximized or minimized as a function of one variable. For the next, find the value of x when dy over dx equal to 0. For the next steps, find the second derivatives and substitute x from 3 to difference between maximized and minimized value. For the last one, to determine the value of y, whether maximize or minimize, substitute x into y. So, the problem statement is an open top box have a square base and a volume of 10 cm cube. We need to find minimum surface area of the box.
So guys, now I'm going to find the solution for how to find the minimum surface area of the box. Let's move on to the first step. The first step, we must to find which one is the volume. Okay, the volume for this box is 10 cm out of 3. So the formula to finding the volume is length times y times the height. So now we know the formula, right? We must make it as a derivative. So 10 a is So A is equal x squared plus 4xh. Now A we assume as a 10 and is equal x squared plus h. Now we know that A is equal x squared plus 4x 10 over by x power of 2. Now we got the derivative, which is x squared plus 4 over x. Let's move on to the step 2.
To find a value x, we use differentiation. So dA over dx are equal to x plus 40 over x squared. So when we to find a minimum or maximum surface, we must use second derivative. So d square a over dx square equal 2 plus 40 over x square. After get the value, we must solve the equation. So x square equal 40 over 2. So x equal root of 20. So x equal 4.47.
We already get the value of x, which is 4.47. So we need to insert the value of x to the equation of h to get the value of h, which is 0.5. After that, we need to find a minimum area of the box. So we need to use formula of area, which is x times h, and that will be 4.47 times 0.5. So the answer will be 2.235 cm cube. So for the last part, we need to prove it the volume from the question is true or not. We need to insert the value of x and h to the formula of volume, which is x squared times h. That will be 4.47 squared times 0.5, and the final answer is 9.99 cm cube.